All right, so for Mother's Day, you're taking your mom out for lunch. The lunch special is $24.99, and a drink is $1.50. Tax is 6%. You're going to tip 25%, so we want to know what the final cost of the meal. So as Ava was pointing out, she goes, well, hey, if you're taking your mom out for lunch, you're paying for her too, right? Yeah. If you don't pay for her, you're not a very good child, So you are taking your mom out for lunch. That means that there are going to be two of you. So when you're trying to figure out the whole, you've got two of you that are going to have $24.99 for the lunch and the $1.50 for the drink. So that's going to come out to $52.98 as your subtotal, your whole. Okay? So remember, that's going to be the bottom portion of our proportion. Okay, and then of course X is what's missing. Now for X, remember we've got to add the percentages together first because we're talking about tax and tip. So we're talking about 6% plus the 25%, which is going to come out to 31% that we're dealing with. So we're going to put 31 over 100. Okay, then we can do the cross product and actually solve. And when we do that, we're going to get that X is equal to $16.42. That stands for your tax and your tip. Okay, that's the combination of the tax and the tip together. Now, the question that they are asking, though, what is the final cost? What on earth was that? Was that you?
Nothing.
What did you throw? 40. 69.40. Okay, so we're adding, hey, remember we're recording. Okay, so for our final price, the final cost, we're going to add, Tanner, we're going to add $52.98 with the $16.42, and that's going to come out to the $69.40. Okay. Okay, if you want to be that obnoxious. Apparently Mason's going to pay with pennies. All right, you have two coupons at Macy's. Shh, quiet. One is for $25. That should say off, not of. That should say $25 off. And the other one is for 25% off. If you're purchasing a sweater for $42.62 and two pairs of jeans for $30.65, then which coupon's the better deal? Is it $25 off or 25% off? So the first thing that you need to figure out is what your subtotal is. So for your subtotal, you know that you're going to be taking your sweater, which is $42.62, and you're going to be adding it with two pairs of jeans that are each going to be $30.65. So it's like $30.65 and another $30.65. That's going to come out to a subtotal of $103.92. Okay, so now we need to figure out $25 off or 25% off. So the only thing you really need to figure out is what is 25% off. If 25% off is more than $25, then that's the better deal. If it's less than $25, then the percentage is not the better deal. Okay, so we're going to check that out. We're going to do X out of $103.92, and we're going to do 25% out of 100. And when we get that, X winds up being $25.98. Okay, so again, this is more. This is more off than $25. Okay, so 25% is the better deal. Okay, because it's a little bit more. 98 cents is still 98 cents, guys. That's still more. Okay, you always want to go with what is the better deal, okay? Because you can only use one. Okay? Yeah, Macy's only allows you to use one coupon at a time. All right. George is purchasing a camera for $650. He has a coupon of 40% off, and tax is 8%. So we want to know how much is he going to be paying. So remember, when we set this up, the first thing we're going to do is find the discount. So we're going to do X out of $650 is equal to the discount, which is 40, out of 100. When we work that out, we're going to get that X is equal to $260, and that's how much we take off. So then we're going to go to step 2, which is to take $650, and we're going to subtract $260, and that gives us our new subtotal of $390. That is our new total. Okay, that's our new total that we're going to be using for the next part. So we're now going to do X over 390, because that's our new total, and we're going to focus on this tax, 8% out of 100. That comes out to $31.26. That is your tax, so you have to add that. So we're now going to take $390, and we're going to add $31.20, and that gives us our final price, which is $421.20. Okay? All right, so that is our multi-step problems with our percentages. I just wanted to make sure that, again, that you guys were okay with those. All right, let's take a look at our next material, which is interest rates. We're going to be talking about simple interest. All right. So this is called the I-party formula. And what simple interest means, if you are planning ever to buy a home, buy a car, maybe go to school, you might have student loans, those kinds of things, they are going to be requiring you to take a loan out. Shh, boys. If you take a loan out, you have to pay interest. Okay, so a lot of times people think, oh man, that's a really good deal on a car. But if you don't pay for the car right up front, then you're going to be paying interest on it. And interest can sometimes be more than what the item is that you're paying for. So for example, my husband and I, we have a 30-year loan on our home. Our home was only like 200 and some change when we bought it. We got it really, really cheap because it was when the housing market was real low. We have a really low interest rate too. Our interest rate is below 3%. But over the course of 3 years, by the time we pay it off, we are going to be paying almost $600,000 on our home total. So even though the price that we bought the home at was only like 220, we're going to be paying a total of 600 because you're going to be paying interest. Interest is a lot. That's how banks make some money. When you borrow money from them, they have to make it worth their while. You pay them interest back, and then they take that money, they're able to invest that. Okay, so these are ways for banks to be able to make a quick turnaround. Okay, but then the same can go for you. You can get a savings account or an IRA, a Roth IRA, which is an investment account. You can go into stocks. You can get CDs. These are all things that are going to accumulate interest for you, so that they are basically giving you money for them holding on to yours. Okay, so they're quick ways to be able to make a nice turnaround on your penny. This is how people retire too. Okay, because when you're working, think about it. You have to pay for all your bills. You've got electric, you've got gas, you've got cell phones, you've got water, you have your car that you have to pay for. You got health insurance that you're going to have to pay for. You have basic needs like food, and if you want to go out and do anything with friends, you've got a lot of stuff that's going on. Your income that you're making is not going to be able to allow you to save enough on your own and still be able to retire at an appropriate age. So that's why you put your money into investment accounts, which allows you to earn interest on them. Okay, you don't touch them, so for years and years and years you never touch those accounts, but they're accumulating these interests so that by the time you're ready to retire, you aren't going to feel the burden of not having a job. Okay, now simple interest is, as we said, it's the simplest form of interest. Most of your accounts are not going to be on simple interest. They're going to be things on like compound interest and bi-weeklies or bi-monthlies or things like that. This is one that is investment over the course of a year, based off of the time frame for a year. So when we have our interest, we have what's called the I-party formula. So how the I-party formula works is you have I, and I is going to represent the money amount of interest. So there's two different kinds of interest that we're going to be talking about today. You have the money amount of interest, and this is the kind of money that you can either earn or money that you're going to owe. It's two different situations. If you're earning it, it's because it's on a savings account. If you're owing it, it's because you borrowed the money from somebody. Okay? And the way that you find the money amount of interest is by doing principal, which is P. That is also money, not Dr. Baggett. Okay, so it's the money amount for principal. This is the money amount that you are either investing or saving into an account, or the amount of money that you're going to take out a loan on, or how much money you're going to borrow from somebody. Okay, so we call that the principal. You're going to multiply it by R, the rate. Okay, and the rate is always going to be your percentage. And we always like to put this percentage over 100. So again, we call this the rate. It's whatever your percentage is, and you want to put it over 100. So if it's 8%, it's 8 over 100. If it's 27%, it's 27 over 100. If it's 0.2%, it's 0.2 over 100. And then T, that is the time. And it's a very specific time, because again, when we're talking about simple interest is only measured in years. It must be in years. Now, if you have it in months, let's say they give it to you in the number of months, you would just take the number of months and you would divide it by how many? 12. If you divide it by 12, that'll give you the years. So like if we have 24 months divided by 12 will give you 2 years. Okay, if you have 3 months, then 3 divided by 12 would give you 0.25 years. Okay, so you always want to put it in the form of years. So there's our I-party formula. Now, sometimes they're going to ask for just the interest in a problem. Sometimes they might want to know what is the final amount. So up here, if they are asking for a final amount, so how much total money are you going to have after so many years, then what you would then do is you would take whatever your principal was and you would add it with the interest, the I. So again, it requires you to read carefully in the problem. Does the problem only want to know how much interest is being earned, or does it want to know how much total money are you going to be owing at the end of this account, or how much total money are you going to have saved into the account for you? Okay, so if we're taking a look here, Liz has an account with $500. It earns 8% simple interest. After 3 years, we want to know how much interest does she have. So we're going to go ahead and fill in the important pieces of information. So we have all of these technically variables, right, what they're all related to. But several of them are going to have values in the problem. So $500, that $500 represents the principal. Okay, she has an account with $500 in it. So we have a principal of $500. We have an interest rate of 8%. So remember, we're going to put that over 100. So it's 8 over 100. And we've got 3 years that we're dealing with. And again, it gave it to us in years, so we're going to replace the time with years. So then all we have to do here is plug it into our formula. That interest is equal to principal, which is 500, times the rate, which is 8 over 100, times the time, which was 3. Okay, so all you have to do is multiply those. 500 times 8 over 100 times 3, and you're going to get that the interest is $120. So after 3 years, they'll earn $120 extra into the account. So again, they only wanted to know how much interest. So we're just looking for I. That's all we're looking for, is what I is going to be. Now, if they asked after 3 years, how much money will she have in the account, that's when you would take the 120 and you would add it with 500. Okay. Why don't you guys try problems 2 through 4 on your own? So for problem number 2, you have Arnold took out a loan for $580. The interest rate was 3%. If he has the loan for 3 months, then how much total will he have to pay back? Jeremy? Good. $584.35. So if we take a look here, okay, the principal was $580, the interest was 3% over 100, and the time this time was in months, so they have to do 3 over 12. 3 months over 12. Okay, so when we multiply 580 times 3 over 100 times 3 over 12, we get $4.35, but the question was how much total is he going to have to pay back? So he has to pay back the loan of $580, and he has to pay back the $4.35 of interest. So he owes a total of $584.35. About number 3, Lewis took out a car loan for $5,000. Takes 2 years to pay it back at 3% interest. So how much did he pay for the car loan? How much is he going to pay for the car loan? Somebody besides Jeremy. Mason, what'd you get? $5,300. Okay, so again, you have to pay back the car loan, and you're going to have to pay back the interest. So we have $5,000 for principal, 3 over 100 for the rate, and the year was 2 years for the time. When we multiply all that, we get $300 for the interest that he's going to owe. You combine that with the loan itself, and he has a total amount that he has to pay back of $5,300. Okay, and then for problem number 4, you place $15,000 into a savings account and earn 1.5% interest over a period of 12 years. So how much money should you have in the account at the end of those 12 years, Ava? $17,700. Good. So again, $15,000 for the principal, 1.5 out of 100 for the rate, and 12 years for the time. When you multiply that, he has an interest earned of $2,700. So he's going to put that into his bank account with that $15,000. So he has $17,700 in the bank account. Now, I want you to go ahead and flip it over to the blank page that's behind it. And I want you to write the following problem. If we have a problem where principal is equal to 2,000 and that the time is equal to 10 years, and that the interest, I, is equal to 1,100, then I want to know what was the rate. So in a situation like this, we would be actually working backwards through it. So we would have the interest, I. We'd be setting that equal to our principal, P, which is 2,000, times the rate, R, which is going to be basically R over 100. We don't know what it is. We don't know what R is going to be, but we're going to put it over 100. And then we're going to multiply it by the time, which in this case is going to be 10. Okay, so there are a few numbers that we can actually multiply together first. We can go ahead and multiply, let me see here. We can multiply 2,000 and we can multiply 10 together. I'm going to rewrite these so that they are side by side, and I'm going to go ahead and multiply those to get what? 20,000. Okay, and then I still have this to be times R over 100, and then this whole thing is still set equal to 1,100. Now I'm trying to solve for R, so what do you think I should do first if I'm solving for R? Jeremy? Not divide by 100 on both sides. Times it by 100 on both sides. So you could do that. I would just say go ahead and divide by the 20,000 first. Just get rid of that. Okay, so if we do the 1,100 and divide it by the 20,000, that's going to give us 0.055 is now equal to R over 100, and then you would know, hey, I need to go ahead and multiply both sides by 100, and that's going to give us 5.5% for our rate. So you can actually work backwards through the problem. Same thing with time. If they give you the rate and they give you the principal and they give you the interest, but they don't know how much years, you could again plug everything in, work backwards through it, and be able to solve for time. Okay, so sometimes they're going to give you all the information for the party, and you have to find the interest, or you have to find the total. Sometimes they're going to give you only bits and pieces, but you're always going to have one item that's missing. All right, you have an assignment. Oh, but it should be a quick one.